Let's watch this video on centroids. To begin, we need to first understand what is a centroid. So, centroid is the geometrical center of an object. Generally, we talk about centroids only when we talk about a two-dimensional space. So, let us see the centroids of various areas today. Okay. So, let me first tell you how to locate a centroid. Then we'll work out a few problems. Okay. Now, given a rectangle, let me assume this is um, B, this side is B and this is H. So, looking at a rectangle is a perfectly symmetrical shape. So, you could probably put the center somewhere here, right? So, locating a centroid just means plotting the x and y coordinates for that particular point. So, this would be, right? Sorry, connected this way. Assuming this is my y-axis, this is my x-axis. So my centroid, my x-coordinate is going to be b by 2 and y-coordinate obviously is going to be h by 2. So locating centroid for a rectangle is straightforward. Now let us go into triangle. For a triangle, the centroid is generally located somewhere near the base and near to this arm which is at right angle. So it would be generally somewhere here, and assuming again this is the base and this is the height. So if I'm going to drop a perpendicular to the base, okay, now this is my x-axis, this is my y-axis. When I drop a perpendicular to the base, it will cut the base at 1 by third of the base, 1/3 of the base. And if I drop a perpendicular to the y, to the h, that is also going to cut at 1/3 of it. Sorry, 1/3. So this centroid will cut the base at 1/3, will cut the height at 1/3, which would mean my x coordinate is going to be b by 3 and my y coordinate is going to be h by 3. Is it always the case with triangles? No. It depends on the orientation. Let us see two other cases. Now my triangle is oriented like this, wherein you will have your y-axis and you will have your x-axis. So where would be the centroid? The centroid is somewhere near the base, near to the right angled arm. It would be somewhere here. So if I need to plot the x coordinate, it would be this distance. Now we know this distance is 1 by 3, which means the remaining distance has to be 2 by 3. So if I'm going to drop a perpendicular here, y coordinate is obviously only 1 by 3. X is, so I will have x as 2b by 3, y as h by 3. Let us take the third case. Now, taking the third case, this being our y coordinate, this being our x coordinate, your centroid is somewhere here, right? So I'm going to drop a perpendicular here and I'm going to drop another perpendicular. Now look at this. Where is this located? So we know this distance is 1 by 3. We also know that this distance is 1 by 3. So when I'm dropping a perpendicular here, so from here, this is the distance. So what will my x be? My x is going to be again 2b by 3. What is y? Y is going to be 2h by 3. So this entire distance, as you can see, is 2b, and this is going to be, sorry, this is going to be 2h by. So it depends on the orientations. The orientation will keep varying. Now, let us take one example. Centroid of an area. I have three rectangles here. This is a C-type one. Let me write the parameters. This is 8 centimeter. This entire length is 8 centimeter. And this thickness is 1.5 centimeter. This is also, give me a minute while I adjust my note. This would also be 1.5 centimeter, and this thickness is 2 centimeter, and this length is 12 centimeter. This entire length. This entire length is 12 centimeter, and this entire length is going to be 10 centimeter. Am I done? Yeah, I am done. So I need to find the centroid of this figure. Maybe it would be somewhere here. Maybe the entire figure. So how do I locate the centroid of this figure? So let me tell you the first steps, right? The first step is sketch an x-axis. Sketch y-axis. This is the first step. Second step is, let us divide this entire figure into three different areas. Is three always mandatory? No. I am I am dividing it into three different areas because that seems the most plausible explanation here. So how am I going to divide it into three different areas? So I am going to have this. I'm going to cut it here. Then I'm going to cut it here as well. Right? So this is one entire area. So I already told you this is 8 centimeter. This is 1.5 centimeter. And this is 10 centimeter. Not the inner length, the outer length. This entire thing is 10 centimeter. This is 1.5 centimeter. This I had told you already is 12 centimeter, right? Remember, this entire length is 12 centimeter. I have cut 1.5 centimeters here. So 12 minus 1.5, it will give me 10.5. Is that the length? No. I have cut another 1.5 centimeters here. So again, I cut another 1.5 here, which would give me 9. So the length of this area is 9. Breadth is, of course, 2 centimeters. So what should you do here? Now let me do here. This is the table which you have to get ready. So figure 1, figure 2 and figure 3 is what we are going to plot. What is figure 1? This is going to be a figure 1, and this is going to be a figure 2, and this is going to be a figure 3. Now figure 1. For figure 1, now this is my x-axis, this is my y-axis. For figure 1, what is the area? 10 into 1.5. Am I right? So I will write here area 10 into 1.5 for figure 1. Then for figure 1, what is your centroid for figure 1 would be somewhere here, right? Let me put this one somewhere so that this is not confusing thing. This is figure 1. Centroid is would be somewhere here. So from the x coordinate, I will drop a perpendicular. This entire length is 10 centimeter. So half of it is going to be, yes, 5. So what is going to be, what is going to be y? Y, I drop a perpendicular here. This entire length is 1.5 centimeter. So half of it is 0.75. Now let me calculate the area of figure 2. For figure 2, what is the length? The modified length is 9. And what is the breadth? The breadth is 2 centimeter. So what do I get? 9 into 2, 18 centimeter. Of course, we fill it up later. Then I need to plot x and y. Now from, let me show it. The center would be somewhere, right? So from here, origin, this will give me the x. So we know this entire thing is 2 centimeter. So half of it, x is going to be 1 centimeter. No issues in that either. Now when you want to point for y, remember we have cut out this area. We have already taken it out, which means this area cannot be included when you calculate the center for this. we have taken out this area, which means we have to consider that area in full. So let me tell you how it goes. Now this entire length is 9 centimeter, right? This entire length is 9 centimeter. Half of it is what? Half of it is 4.5. We all know this. This entire length is 9 and half of it is 4.5. But before that, there is one area and that entire length is 1.5. That has to be taken in full. The common mistake you might do is you will take 10.5 divided by 2, or alternatively you will take entire 12 divided by 2, you will put 6. No. We take this area as a standalone. We take this area as a standalone. As a standalone, what is the length of it? It is 9 centimeter. What is half of it? 4.5. What is the y coordinate of it? You must add the 1.5 before it. So 4.5 plus 1.5 would give you 6. Let us do it for the third figure. You might understand it even better. For the third figure, what is the area? 8 into 1.5. So you will write here 8 into 1.5. What is x? For the third figure, again, your x would be somewhere here. So length 8. The entire thing is 8 divided by 2, 4. This is fine. Now y, coming to y. Remember, this entire length is before that. This entire length is before that. This is a standalone figure, standalone area. So what is the y coordinate of this standalone area? This entire length is 1.5. Half of that is what? 0.75. But I need the y coordinate, not just of this figure. Before this, there is one entire length. What is this entire length? This entire length is 9 plus 1.5, which is 10.5. So 0.75 plus 10.5. So that is what you will write here. You will write here 11.25. Now, if you see, I have put in AX, I have put in also AY, right? I have put in AX, give me a minute. I have put in AX and AY here. And what is AX? This area into this X. It is here. This area into this X. Then area into Y I have put here. So I have summed up all three. Sigma, you can see the sigma. I have added up all three. I have added up all three. So now I have to find the centroid of the entire figure. I have not given the formula yet. So I'll give you the formula now. Centroid for the entire figure x bar is given by sigma ai xi by sigma ai, which is summation of ax. What is this here? That is 141 divided by summation of area, which is 45. So what does that work out to be? That works out to be 3.13 centimeter. Now I need to find out y bar. So sigma ai yi by sigma ai. Yi is 254.25 divided by 45, and I have worked it out. It works out to be 56.5 centimeter. This is the centroid of the entire figure. Let me go through this once again, then we'll do other examples also. Okay. So I have been given a C-type area. I need to split it into 3 different parts. I am taking this as one entire part. I have cut it and take it out. But it is there. I have cut it and taken it out, but it is there on the x-axis, right? Then I am placing this fellow on top of this horizontal line. And then I am placing this on top of this horizontal and vertical. So this is a standalone, this is a standalone, this is a standalone. They are put together. That is how we assume. So center of this is 5. Center of this is 1.5, absolutely fine. When you need to find the center of this from the x-axis and y-axis, what do you do for y? For x, it is fine. It is directly from here. from the from the y-axis, you find the distance that will give you the x-coordinate. In the case of y-coordinate, the distance from the x-axis has to be calculated. Calculate half of this standalone, which is 4.5. Then add whatever is before that, 4.5 plus 1.5, 6. So we do follow the same for this, and this is the answer we get. We will see few more examples. Now we have two areas here, one rectangle and one triangle. So what is the first thing you do? First thing you do is put a y-axis and x-axis. I have not given you the parameters. Let me give you the parameters now. The parameters are, okay, I have a, this is 6 centimeter. Okay. This is 4 centimeter. And this entire length is 9 centimeter. 6, this is 4. This entire length is 9 centimeter. If this entire length is 9 centimeter, this is 6 centimeter. We know this is going to be 3 centimeter. Now we need to find centroid of this. We need to find centroid of this, taking this into consideration. Then we need to find the centroid of the entire figure. So step 1, draw the x and y coordinates. Step 2, identify the areas where you have to find the centroid. Step 3, use the formula to find the centroid of the entire figure. Of course, in the middle, you'll also have to use the table. That goes with step 2. Okay. So this is the table as we have seen earlier. Now I have a rectangle here. I have to find the area of the rectangle. 4 into 6. Area in centimeter square, 4 into 6. Now, the center for this rectangle would somewhere be here. Geometrical center, remember. So I have to find the x coordinate and the y coordinate. X coordinate is half of 6 and y coordinate is half of 4. So 3, 2. Now let us go to the, let us go to the triangle. When you go to the triangle, your base is 3, your height is 4. And what is the area of the triangle? Half base into height. Now, x for triangle. I told you your centroid for triangle is located somewhere here. And it can be calculated, the x coordinate and y coordinate of this triangle alone is given by h by 3 and b by 3. Now, if you need to find out the x coordinate, you will have 3 by 3 plus this entire 6. So, what will you have? 6 plus 3 by 3, which is 7. What about the y coordinate? Y coordinate is fine. Y coordinate is just 4 by 3. Why do I say this? I say this because before this, there is nothing in the along the y coordinate. But here there is a rectangle which is sitting here. So your x coordinate, this has to be added. Y coordinate directly maps to this. So now having filled this, I filled up the table for you. Area x, y, ax, ay. So what should you do then? Sigma, sorry, x is equal to sigma ai xi divided by sigma ai. So what is it? Sigma ai xi is 114 divided by 30, and that would give me, it says it's 3.8 centimeter, and sigma, sorry, and my y is going to be sigma ai yi by sigma ai, which is again 56 divided by 30, which is going to be 1.87 centimeter. This is the x coordinate and y coordinate. So remember, given a figure, we are going to work out more. Given a figure, first put it along x and y coordinate, get a table ready, find the area. So first you should know how to isolate the areas, then find the area of each of them, find x, find y, find ax, find ay, add them. And once you get, once you know how to separate the areas, once you're able to visualize, rest is going to be definitely easy. Yes, we have one more here. Find the centroid of this area. First step. So we are separating this, but first step we'll put it into x-axis and y-axis. I've separated it here to give you an idea that you can make a triangle and you can make a rectangle. This is a triangle. This is a rectangle. So let me take the coordinates first. So when I take the coordinates here, what do I have here? I have uh, this is 54 millimeter and this is 36 millimeter. This is 45 millimeter. This is, forgive the dimensions I have drawn. This is 30 millimeter. So I have two different areas. I have a rectangle, I have a triangle. So now you know how it goes. So what do I do? So for rectangle, I'll have to find out the area. So what is the area of the rectangle? Add both of them. Add both of them. So 54 plus 36, which would give you 90 into 30. 30. This is millimeter square. So millimeter. All these are millimeter. 90 into 30. Then what is the x coordinate? So this entire thing is 30. Okay. This entire thing is 30. So half of that, what is going to be? It's going to be 15 millimeter. So I need to find out y. Again, it is simple. This entire length is 90. So half of that is going to be 45. No issue. Now we'll have to find for triangle. For triangle, your centroid is located somewhere. Okay. So this will be 1 by 3. What is your x? So b by 3. So what is it? This length I have given you as 45 millimeter. So 45 by 3 along x is 15 millimeter plus 13 millimeter. So what do I have here? Along x, I am going to have 45. Before that, the area half into what is my base? Base is 45. What is the height? Height is 54. 45 into 54. Now, what is my y? So, your y, this part is going to be 54 divided by 3. So, it is 54 divided by 3 plus this length. What is this length? 36. That is going to be my y. So, 54 divided by 3 plus 36. So I have these parameters here. So again, I'm not going to work it out for you. I think you can do it yourself. This divided by this will give you x coordinate and this divided by this is going to give y coordinate, right? Try it out for yourself. Okay, we'll meet in the next video.